Hi, my name is Josh, and this is Lab 3, Magnetic Field of a Bar Magnet. In this lab, the concepts that I'm going to go over is about magnetic fields and the Biot-Savart law. The problem that I faced was finding the distance dependence of a magnetic field from a bar magnet at different locations around the magnet and compare results with equations for the on and off axis magnetic fields found using the Biot-Savart law. The procedure that I used during this experiment was first to align the magnetometer from my phone with Earth's magnetic poles. I made sure to stay away from any metallic and magnetic objects during the experiment. I aligned the phone with Earth's north-south axis by getting the x component of the magnetic field measurement as close to zero as possible to compensate for Earth's magnetic field. I found magnetic chip by aligning phone horizontally and vertically with bar magnet. And then I measured distances, which made the x component of the magnetometer read 20, 70, 120, 170, and 220 microtelsas. And then to find off-axis magnetic field, I measured phone 100 microteslas horizontally from the magnet, and then the same distance vertically, and then measured the y value. What I observed was when the magnetometer is far from the magnet, it measures a near zero magnetic field in the x direction. And then as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. The equation I used is seen here with the B bar. The magnetic field of the bar magnet is proportional to K constant times distance r to the power of n. And then by taking the natural log, I was able to show a form that allows us to measure the constant value of n by plotting natural log of bx and the natural log of r on a graph, since bx and r vary. And the value that I found for n was negative 2.4652. The equations I used to find mu was taking the e of the y-intercept found in the graph in the next slide, and then I set r equal to 1 to find the y-intercept, since the natural log of 1 equals 0. And when I did that, I found mu to be 4.73 times 10 to the negative 3 amps squared. And this is the data that I measured from the magnetometer to the magnet at distances that vary on the left, and the trend that was found in the spreadsheet. I was able to use that data to find mu in the previous equation. The next part of my data was using the off-axis magnetic field, and the experimental B at distance d I found to be negative 1.349 e to the negative 9th, negative 3.91 e to the negative 8th, and then negative 4.1 e to the negative 8th teslas. And then when I found the magnitude of that, it is 5.8 negative 8 teslas. In GlowScript, I found that the magnetic field at distance d was 2.47749 teslas, and all of the breakup between the different areas around the magnet can be seen here. And the difference between this result from the experimental data that I found in the last slide is from different experimental results, inaccuracies, such as magnetic fields interrupting with the test, as well as different magnet objects, such as the metal bars maybe in the table. So in conclusion, if I had not oriented the magnetometer with the magnetic north and then laid the meter stick at some intermediate angle with respect to Earth's magnetic field, the trend on the graph would be the same, since the magnet still affects the phone. However, the values themselves would be different, since Earth's magnetic field would be interfering with the measurements. The biggest difference could be seen in the theoretical and experimental results, since the theoretical would take into consideration Earth's magnetic field and the experimental results would not. And what if you were to stick two identical magnets together end to end and run the experiment again? Well, the measurements would be doubled, since the new magnetic field would have the magnetic field of each magnet put together. Thank you for listening.